This project outlines the development of a Golang-based priority queue system ensuring efficient queue operations. For efficient task and process management in modern software systems, we require a priority queue. It is a type of data structures that processes elements based on a certain priority instead of order of arrival, such as FIFO systems, etc. This project presents a web-based priority queue application built using Go programming for backend processing and a simple HTML CSS JS system for front-end for user interaction. The application utilizes RESTful APIs for proper handling of Go and priority queue operations such as addition, removal, update, etc. And Go's concurrency models and performance efficiency make an excellent choice for managing queue operations at a small scale. The problem employs and looks at task prioritization challenges. Managing task priorities is a crucial and important task in the modern world in itself. With an increasing number of tasks, outdated methods such as F first and first out result in inefficient processing of data and delays. In this manner, a well structured priority queue can come up as a boon for proper handling of data. And user interface needs are another aspects that need to be handled properly. A well-designed UI enhances user experience by simplifying interactions with the system. Utilizing modern web technologies can facilitate this very idea. For the backend robustness, a robust backend is extremely essential, ensuring seamless organization and movement between the backend and the front-end flow of data. Data has to be efficiently handled and loaded under all circumstances, and using Go, which offers excellent concurrency support, we can streamline these processes and ensure that the backend remains responsive and efficient. For implementation, the front end is implemented using HTML, CSS, and JavaScript, ensuring dynamic and responsive user interface. Go's coroutines work seamlessly with handling concurrent operations, which makes it ideal for queue management. The API architecture is defined in the system and the code, where several well-defined endpoints are breaked and allowed, which allows front-end interaction with the backend. Key operations are included, such as addition of tasks, removal of tasks, peaking, etc., based on their priority. Each endpoint is designed to perform efficiently and ensuring minimal latency for the users. Implementation details. So we can look at the code, for instance. So here we have our Go project. So we have our main Go file where we have imported JSON, logs, HTTP, etc. for giving proper handling with an HTML JSON based front end. We are defining the structure for these items in our APIs and responses for the API response structure. We are defining a main function where we're handling all of the API endpoints. And similarly, we're defining a local host where the application will be run. And similarly, we are utilizing handle add, handle remove these functions and utilizing locks with them to ensure proper and seamless organization of operations without one operation overtaking the other. In this regard, we've also implemented the priority queue system, which utilizes the container heap. In this, we have implemented the priority queue itself, ensuring various different queue operations such as push, pop, swap, update, peak, etc. For the front end, we are utilizing simple HTML, CSS, and JavaScript systems. In the JavaScript, as we can see, we have defined our APIs with the names add, remove, update, etc. And we are calling API call functions to define the API and ensure proper JSONification of the data and stringification of it. Then we are defining functions where we are taking the, for instance, the update function for the queue and where the data item and data ID is properly implemented for seamless organization and updation. Similarly, remove items, peak items, update items. These specific functions are properly defined in order to ensure the system works properly. So here is our system. So for example, we have here included a task B with the priority of 4. So if we try to peak at the highest priority, we can look at it that the highest priority is 4. We can add another task. For example, we add task A and we can let the task A's priority be 3 and we can add that item. And as we can see, the task A's priority is implemented here with priority 3. Similarly, we can add further tasks. So task C, and we can have the priority be 8. So we add the item. And now as we can see, task C has the highest priority of 8. So if we check the peak, it will show us that the highest priority belongs to task C. Similarly, we can delete the highest priority as well. So we remove it, and when we check it again, it falls back to task B with the priority of 4. Similarly, we can update the items. So we can give the item ID as defined here. So for instance, we change task A. So item ID 1, task A, we can keep the name as is or we can change it, and we can set priority to 10. The higher the priority number, the higher its importance. So now if we check the highest priority, it becomes task A with a priority of 10. In this manner, the conclusion can be outlined that the project is properly employed for development and it properly utilizes priority queues and goes, utilizing Go routines and concurrency model efficiencies and goes to handle priority queue functions in Golang. Thank you.